Okay, so today I'm not going to really be drawing anything. We're going to just go over a couple of shapes and their names and why they are the shapes that they are. And then tomorrow is polarity, and then we will go over a few of these examples in the next video. We'll keep this one pretty short. I'm actually at school during school, so there's no telling who's going to knock on the door or come in. But let's just get started. So the valence shell electron pair repulsion theory is just, I kind of alluded to it in the last video, where the electrons are going to kind of be pushed away from each other, kind of like certain ends of the magnet are pushed, they repel each other. Well, these electrons are going to also push away from each other as far as the actual pairs of electrons, not each electron, but each pair. And the repelling of these electrons is actually what will determine the shape of the molecule. So the first shape we're going to talk about is linear. So for example, H2, linear, it would be a linear molecule. So you would have a hydrogen here and a hydrogen here, and they would be each sharing their one electron here to make a complete bond. And also you can have another linear shape with 3 atoms. The only thing you need to know about, or the main thing you need to know about this, is that the middle atom here doesn't have any electrons. When it says unshared pairs, that's this. This right here is an unshared pair, okay? So you don't see any here. Carbon has 4 electrons. 4 valence electrons, I'm sorry. And then there's 1 in this bond, there's 1 electron in this bond, and 1 in here, and 1 in here. So it has no extra electrons here, and that's why it can be a straight line in its molecule. Okay, so the next shape we're going to go over is bent. This is the water molecule that we drew the other day. And basically, it's just a central atom with 1 or 2 pairs of unshared electrons, okay? And these electrons right here, think of them as more negative than the actual bond. So these are going to push down the bonds and making them kind of a smaller angle. So here is an actual example, and we've drawn this already in one of the lessons. So the next shape is trigonal planar. And basically, when you have trigonal planar, you don't have any extra electrons. So you don't have any extra electrons. So if you don't have extra electrons, usually this is how you would have to do it. One would have to be a double bond, causing this one to have a couple of unpaired electrons as well. Or maybe not. Maybe it's a hydrogen. I don't know. But here is one example. But just make sure that the central atom doesn't have any extra electrons either. Oh, also, these bond angles are really for your own information. I'm sorry. All right, so on the test, you do not have to memorize the bond angles. However, in IB, you will be expected to know them, but you'll obviously revisit them. Just know that these bond angles are different per shape. All right, and then pyramid. Pyramid will have lone pairs of electrons, and then this actual pair of electron will push all of the other atoms down. So one example that you'll see often is nitrogen with 3 hydrogens connected to it. And if you'll notice, nitrogen has 5 valence electrons. So there's 1 in this bond, 1 in this bond, 1 in this bond, and then 2 here. So there's your 5 electrons with nitrogen. And then obviously each hydrogen has 1 electron that it's also contributing in this bond. And notice the angle here. Keep in mind that this hydrogen atom is actually pushed out into, or I'm sorry, pushed back out of the paper or screen, and so is this one, and then this one would be coming towards you, but we'll talk about that in class, and I'll show you some models as well. All right, next shape is tetrahedral. So tetrahedral, again, the central atom has no unshared electrons, and it has 4 other atoms connected to it. So methane is a common example of a tetrahedral shape. And notice the bond angle. And trigonal bipyramidal, this one is a weird one. It breaks the octet rule. So, for example, there will be more than 8 electrons sharing here, so sharing in this central atom. So, for example, only certain atoms can handle this type of bond, and that's the elements in period 3 when bonded only to chlorine or fluorine. So you'll see phosphorus bonded with chlorine or fluorine in some of the examples, but just know that it is possible to have 5 bonds. Remember, this is not flat on an actual piece of paper, that these molecules are 3D. So some of them are coming at you, some of them are going out of the paper, some of them are in line with the paper. So the central atom will have an expanded octet, which means it will have more than 8 electrons sharing it. So there's actually 10 electrons around the phosphorus here. And it has multiple bond angles, but so do the others. And then here's just a summary of the shapes. So it really just helps to do multiple examples of this, which we won't do today. We will be doing them in class, and we'll be doing some homework examples. I highly suggest you pay attention in class whenever we're going over some of these examples. That way the test doesn't just sneak up on you and you're not quite sure how to draw these molecules. And then once we do polarity, I'll do a couple of examples of these shapes in the next video. But in this video, my main goal was to get you guys familiar with the terminology and what these look like. So with linear, obviously that name kind of is self-explanatory. There are no middle lone pairs in the middle atom. You can have 2 or 3 atoms connected to each other. Bent, these electrons right here are repelling these down here, so they're being pushed down. Same with this. Trigonal planar, this is no, there are no lone pairs here, and usually this one is a double bond. And pyramid is basically you have not a double bond here, but a lone pair pushing all 3 of these down. Usually it's like an NH3 with extra electrons. Tetrahedral is just 4 atoms connected to the center, and trigonal bipyramidal, this is that weird one. It has a weird name and a weird shape. It goes against the rules, so this one will be easy to remember. This one will be easy to remember. These 2 will be easy to remember. So really the ones that kind of trip up my students are usually these 2 right here, but then even the pyramid kind of looks like a pyramid, so it's really the trigonal planar and the tetrahedral that they tend to get confused on. So don't freak out because these are new and weird terms and shapes. This is actually not that bad once you realize that this one's weird, this one, and this one's weird, or obvious. I'm sorry, not weird, but obvious. And then these 3 kind of just get these 2 straight and you'll know pyramid.